Basic concepts in geometry.
Introduction.
Did you recognize the adjacent picture? It is a picture of pyramids in Egypt, built 3000 years before Christian era. How the people were able to build such huge structures in so old time? It is not possible to build such huge structures without developed knowledge of geometry and engineering. The word geometry itself suggests the origin of the subject. It is generated from Greek words geo, which means earth, and metria, which means measuring. So, it can be guessed that the subject must have evolved from the need of measuring the earth, that is, land. Geometry was developed in many nations in different periods and for different construction. The first Greek mathematician, Thales, had gone to Egypt. It is said that he determined height of a pyramid by measuring its shadow and using properties of similar triangles. Ancient Indians also had deep knowledge of geometry. In Vedic period, people used geometrical properties to build altars. The book Shulva Sutra describes how to build different shapes by taking measurements with the help of a string. In course of time, the mathematicians Aryabhatta, Varaha Mihir, Brahmagupta, Bhaskaracharya, and many others have given valuable contribution to the subject of geometry. Let's learn basic concept in geometry, that is, point, line, and plane. We do not define numbers. Similarly, we do not define a point, line, and plane also. These are some basic concepts in geometry. Lines and planes are set of points. Keep in mind that the word line is used in the sense straight line. Coordinates of points and distance. Observe the following number line. Here, the point D on the number line denotes the number 1. So, it is said that 1 is the coordinate of point D. The point B denotes the number -3 on the line. Hence, the coordinate of point B is -3. Similarly, the coordinate of point A and E are -5 and 3 respectively. The point E is 2 units away from point D. It means the distance between points D and E is 2. Thus, we can find the distance between 2 points on a number line by counting the number of units. The distance between point A and B on the above number line is also 2. Now, let us see how to find distance with the help of coordinates of points. To find the distance between 2 points, consider their coordinates and subtract the smaller coordinate from the larger. The coordinate of point D and E are 1 and 3 respectively. We know that 3 is greater than 1. Therefore, distance between point E and D is equal to 3 minus 1, which is equal to 2. The distance between E and D is denoted as distance ED. This is same as length ED. That is, the length of the segment ED. Distance ED is equal to 3 minus 1, which is equal to 2. Therefore, length of ED is equal to 2. Distance ED is equal to length of ED, which is equal to 2. Similarly, distance of DE is equal to 2. Distance of CD is equal to 1 minus 2 in brackets, which is equal to 1 plus 2, which is equal to 3. Therefore, distance of CD is equal to length of CD, which is equal to 3. Similarly, distance of DC is equal to 3. Now, let us find distance of AB. The coordinate of A is -5 and that of B is -3. -3 is greater than -5. Therefore, distance of AB is equal to -3 minus -5 in brackets, which is equal to -3 plus 5, which is equal to 2. From the above example, it is clear that the distance between two distinct points is always a positive number. Note that if the 2 points are not distinct, then the distance between them is 0. Remember this. The distance between 2 points is obtained by subtracting the smaller coordinate from the larger coordinate. The distance between any 2 points is a non-negative real number. Betweenness. Let's learn. If P, Q, R are 3 distinct collinear points, there are 3 possibilities. 1. Point Q is between P and R. 2. Point R is between P and Q. 3. Point P is between R and Q. If distance of PQ plus distance of QR is equal to distance of PR, then it is said that point Q is between P and R. The betweenness is shown as P dash Q dash R. Let's see some solved examples. Example 1. On a number line, point A, B and C are such that distance of AB is equal to 5. Distance of BC is equal to 11. And distance of AC is equal to 6. Which of the points is between the other two? Solution. Which of the points A, B and C is between the other two can be decided as follows. Distance of BC is equal to 11. Let us mark this equation as 1. Distance of AB plus distance of AC is equal to 5 plus 6, which is equal to 11. Let us mark this equation as 2. Therefore, distance of BC is equal to distance of AB plus distance of AC. From equation 1 and 2. Point A is between point B and C. Example 2. U, V and A are 3 cities on a straight road. The distance between U and A is 215 kilometers. Between V and A is 140 kilometers. And between U and V is 75 kilometers. which of them is between the other two? Solution. Distance of UA is equal to 215. Distance of VA is equal to 140. Distance of UV is equal to 75. Distance of UV plus distance of VA is equal to 75 plus 140, which is equal to 215. Distance of UA is equal to 215. Therefore, distance of UA is equal to distance of UV plus distance of VA. Therefore, the city V is between the cities U and A. Example 3. The coordinate of point A on a number line is 5. Find the coordinate of point on the number line which are 13 units away from A. Solution. As shown in the figure, let us take point T and D to the left and right of A respectively at a distance of 13 units. The coordinate of point T, which is to the left of A, will be 5 minus 13, which is equal to minus 8. The coordinate of point D, which is to the right of A, will be 5 plus 13, which is equal to 18. Therefore, the coordinate of points 13 units away from A will be minus 8 and 18. Verify your answer. Distance of AD is equal to distance of AT, which is equal to 13. Activity 1. Point A, B, C are given a side. Check with a stretched thread whether the 3 points are collinear. Write which of them is between the other two. 2. Given a side are 4 points P, Q, R and S. Check which 3 of them are collinear and which 3 are non-collinear. In case of 3 collinear points, state which of them is between the other two. 3. Students are asked to stand in a line for mass drill. How will you check whether the students standing are in a line or not? 4. How had you verified that light rays travel in a straight line? Recall an experiment in science which you have done in a previous standard.